The process we'll be looking at is a wastewater treatment process. You may not have any experience with this type of process, but you can apply the basic troubleshooting approach you'll see to processes that you work with. This wastewater treatment system is divided into 5 sections, a collection section and 4 treatment stages. The collection section includes a sewer system that routes wastewater to the rest of the wastewater treatment system. The first stage of treatment is called primary treatment. Its function is to remove quick-settling solids from the wastewater and separate out certain other materials such as oil. The next stage, called intermediate treatment, eliminates dissolved solids and very fine suspended solids. The third stage of treatment is called secondary treatment. Here, organic material is decomposed and removed. The final stage is called tertiary treatment or advanced treatment. In this stage, any remaining organic and inorganic impurities are removed before the water is discharged or returned to the plant for reuse. The primary, intermediate, and secondary stages all contain devices called clarifiers. Clarifiers remove suspended solids from the wastewater. This wastewater treatment system also treats sludge, which settles to the bottom of the water in the clarifiers. The sludge in the bottom of a clarifier is often referred to as a sludge blanket. In this part, we're going to see how a troubleshooting procedure can be used to find and correct a problem in a wastewater treatment system. To better show how different techniques can be used, several of the process of elimination methods are used in this example. When a problem occurs, the first step in troubleshooting it is to identify the problem. In this example, an operator detects a high sludge blanket level in the clarifier for the secondary treatment stage. The sludge blanket in a clarifier acts as a filter to trap suspended solids in the wastewater. However, if the sludge blanket level gets too high, solids could be carried over into the next treatment stage. Another result could be insufficient removal of impurities from the wastewater leaving the treatment system. Also, the pH of the water leaving the treatment system could be affected. After identifying the problem, the operator's next step is to take preventive action. A high sludge blanket level can affect the pH of the water leaving the treatment system. In this example, the operator is able to adjust the pH of the water during the final stage of treatment. When the preventive action of adjusting the water's pH is taken, the treatment system can continue to operate. However, the cause of the problem has not yet been determined. To determine the cause of the problem, the operator has to consider a number of possibilities and eliminate them until there is only one possible cause. Since the problem has been detected in the secondary clarifier, the operator can eliminate the tertiary treatment section as a source of the problem. Next, the operator decides to use bracketing to narrow down the location of the problem. In this example, the operator establishes boundaries around the remaining sections of the treatment system one at a time. First, he checks the secondary treatment stage. The operator finds that the clarifier is working properly and that the values of the other process variables are within their normal ranges. Basically, all indications except the sludge blanket level appear to be normal. So the operator rules out the secondary stage of the treatment process as a source of the problem. The operator decides to check the collection section next. He knows that the high sludge blanket level in the secondary stage could be caused by the entrance of wastewater with a high solids content. If water with a high solids content drains into the collection section, the solids could get carried all the way through the treatment system. Along the way, they would build up in the clarifiers and increase the sludge blanket levels. When he discusses the situation with other operators, the operator learns that there has been no significant change in the water entering the treatment system. So the collection section of the treatment system is probably not the source of the problem. At this point, the operator has bracketed the cause of the problem to somewhere in the primary treatment stage or the intermediate treatment stage. To eliminate one of these stages, the operator applies the half-splitting technique. To split the remaining possibilities, the operator checks the sludge blanket level in the primary clarifier. The primary clarifier is the last piece of equipment in the primary stage. If its sludge blanket level is normal, the cause of the problem is somewhere in the intermediate treatment stage. If the level is too high, the cause must be in the primary treatment stage. The operator finds the sludge blanket level in the primary clarifier is too high, so the problem must be in the primary treatment stage. The primary treatment stage includes screens, pH adjustment equipment, and the clarifier. The operator decides to use the serial method to check these components. When the operator checks the screens, he notices that the water spray system that is used to clean the screens is not operating. This has allowed material trapped on the screen to re-enter the water and flow into the clarifier. Further investigation shows that the pump that supplies water to the water spray system has broken down. This is the cause of the problem. To correct the problem, the operator has a backup water spray pump started. He also reports the broken pump so that it can be repaired. At this point, the cause of the problem has been found and corrected, and the operator can return the system to normal operation. To do this, the operator readjusts the pH of the water leaving the treatment system.